Hi everyone, welcome to Wireless Sensor Network lecture series. Myself Sivalakshmi, working at RMK College of Engineering and Technology. In today's lecture, we are going to see what is the type of network used for WSN and which network is called as ad hoc network, what are the challenges faced by the ad hoc networks, and what are the application scenarios of WSN and how the deployments are made in WSN. So basically, network is of two types, infrastructure based and infrastructure free network. So the same applies to the wireless networks also. Even they could be of two types, infrastructure based wireless networks and infrastructure free wireless network structures. In earlier days, we made use of infrastructure based wireless networks. Example, your GSM, UMTS. GSM is nothing but which stands for Global System Mobile Communication, and UMTS is your Universal Mobile Telecommunication Systems. So earlier days, all the cellular network made use of this infrastructure. A sample could be seen where you have a backbone IP backbone structure where in this all the devices were connected through a wired medium, and even the base stations were connected to the backbone through a wired medium, wherein the mobile networks, the end devices, are connected to the base stations through wireless. So if any two mobile entities wants to transfer packets now, it is possible only through the base station, and via the backbone they will be try to communicate with the other end of the device. So the backbone structure is not only used for relaying the packets but also to perform some administrative task. So this is the concept of your infrastructure based networks. Here the backbone of the, so what is the main thing you have to remember now? A part of the network involves a wired medium wherein one end of the network is wireless. Okay. So next comes, we have so many limitations for infrastructure based wireless networks. Here mainly we have listed three. For certain areas, this infrastructure is not available. For certain areas, it is too expensive to implement, and in certain cases, it is found to be inconvenient to set up. Also, for certain areas, there is no time to set it up. So examples for all the above listed limitations we have given here, as like we have many. Okay. The solution for the proposed limitations were trying to implement or trying to adapt to the infrastructure free networks. The other name is ad hoc networks. Why the name ad hoc now? It is a Latin word meaning for this. So what is our motive is we are trying to build a network for a specific purpose to satisfy a specific purpose. So that is why we call those networks as a ad hoc networks. So simply speaking, an ad hoc network is a network constructed for a special purposes. It is nothing but without a infrastructure uses the abilities of the participants. Here the participants are nothing but the source node and the sink nodes. The best example and also the simplest example for an ad hoc network is laptops in a conference room, which is nothing but a single hop ad hoc network as shown in the figure. What are the possible applications for infrastructure free networks, that is your ad hoc networks now? Here few I've listed, like it could be easily imposed for factory floor automation systems, and for a disaster recovery and car to car communication. So in other words, I could say that WSN, which involves ad hoc network structure, invokes, or it could be called as an enabler, as we discussed in the earlier lecture. We told that WSN will act as an enabler to IoT. So for VANETs, vehicle to vehicle communication to happen, WSN would be the enabler for VANETs and MANETs to happen. And in certain other applications also could be used. What are they? In military networking, and to find out empty spaces in the parking lots, for search and rescue operations, and even for our personal area networking. So the challenges faced by ad hoc networks are usually, the first comes into picture is the lack of central entity for an organization, available organization. Next comes the limited range of wireless communication. Here the participants will be always in mobility, and the power supply used is a battery. Energy efficiency comes into picture. So these are the main challenges faced by ad hoc networks: lack of central entity, limited range of communication, mobility of the participants, and it is a battery operated entity. So for these challenges, they have proposed solutions through the protocols. So here the first challenge is no central entity. So the solution for this is the self-organization with a base station. So as I've stated earlier, without a central entity like a base station, participants must organize themselves into a network. So that means they have to be self-organized. So this mechanism of self-organization can be imposed into that hardware with the help of a protocol called medium access control and routing protocols. With the help of these two protocols, we can make a entity that is either a sensor node or a sync node to be a self-organized one. So this is a solution for the first challenge. Our second challenge was limited range of communication. Solution could be multi-hopping, because if a source wants to communicate with a destined device which is at a very long distance now, they need not directly try to communicate, because if they do so, high power is required, transmission power is required, and in between they might also face obstacles, so there will be loss of information. So always they don't propose direct communication. Direct communication is limited if it's a long distance communication now. So if we are into that kind of situations now, instead of directly trying to communicate, we can have multiple hoppings in between, so that this could avoid and be a best solution for the limited range of communication. Our next challenge was mobility of the participants. Here, whomever the participants across the area we are concentrating on, in earlier days in the cellular network, when one entity moved from one area to the other area, they can just hand over to the another base station without affecting the scenarios, and it was an easy one because they are infrastructure based. Wherein in mobile ad hoc networks, that is your MANETs, mobility changes the neighborhood relationship, and it is more complicated when it comes to routing routes in the network, and that too when it is in a larger scales of nodes now, it becomes too complicated. But nowadays it is being compensated by adaptive routing protocols, so even that is not a problem nowadays. Mobility is allowed and adapted. Okay. The last challenge for WSN was that it is a battery operated device. In earlier days, they tried imposing certain mechanisms to consume low energy. So those mechanisms were imposed into those devices as protocols. Basically, they call those protocols set of protocols to impose these mechanisms. They call it as a energy efficient routing protocols or the networking protocols. Basically, they'll check for the multi-hop routes with low energy consumption, and also sometimes they try to take into account the battery capacity of the every devices, and based on that they would try to choose the next hop to whichever the device which has more power or energy. So this was a mechanism followed in the earlier days, but right now in 21st centuries we have solutions for long run with the help of energy harvesting technique. For example, solar panels. So we are far way from this challenge. So it is not a problem at all nowadays. So finally, so far we have discussed all about the types of networks basically available, and specifically to WSN and to which network we adopted and what is the reason. WSN adopts the ad hoc network structure. Why the name ad hoc and the challenges faced by ad hoc networks. So far we have discussed these things. So finally, what is all about wireless sensor networks? In earlier days, the participants in the previous examples were devices close to human user interacting with humans. So in earlier networks, the devices used to interact with the humans and humans with the humans. The alternative concept, instead of focusing the interaction on humans, focus on interacting with the environment. So this alternative concept is your wireless sensor network's main objective. It is a network embedded in environment. Nodes in the network are equipped with sensing and actuation to measure and influence the environment respectively. Nodes process information and communicate it wirelessly. The other name for wireless sensor network is wireless sensor and actuator networks. So now we have a clear picture of wireless sensor networks. In the earlier class also we have seen a few examples. Here I have come out with few more. The WSN applications could be extended to disaster relief operations, biodiversity mapping, intelligent buildings. The other applications are intrusion detection systems, machine surveillance and preventive maintenance, precision agriculture, medicine and healthcare, logistics, telematics. The roles of the participants in WSN. So far we were mentioning participants in WSN. They are nothing but the source, sink and the actuators. Source are nothing but the sensors deployed somewhere used to measure and report to the intended interested sink nodes. So what are sink? Sinks are nothing but, or the sink node is nothing but, it's a sinks of data interested in receiving data from WSN. Sometimes it would be a part of a WSN or it would be an external entity, or sometimes a personal device, digital assistants like your mobile phones. That is, you will gather the information from your sensor, that is the source, directly in your mobile. And you will also sometimes try to control the environment based on the sensed information. At that time, the same device could be acting as an actuator. So the instruction will be delivered through the mobile with the help of some devices deployed at the controlling site. We call it as a control device or the actuators. The environment could be controlled. So who are the participants or the components of WSN? Source, sink and the actuator. And as I've stated initially, the structuring of WSN application types could be also done based on the source and sink communication. How the interaction pattern is between them. Say suppose if it is continuously happening now, then we can classify those kind of applications under periodic measurements. Say suppose if you are trying to monitor the temperature of a particular area continuously now, to be more precise, I can even say or categorize under function approximation, which is under the periodic measurement. Say suppose if you want to periodically monitor the edges of the structures or the buildings, or to find out the health conditions of the buildings now, then they could also go for edge deductions. Say suppose if the structure has changed, any landscaping is happening, even those could be found out. So if any communications happens continuously between sources and sinks now, that could be categorized under periodic measurement or periodic monitoring. Okay, the next classification could be event detection, or to be more specific, event classification. Whenever an event has happened, an unintended event has happened now, the source will try to communicate with the sink only when an event has occurred now. If that kind of communication is happening now, then we can classify all those applications under event detections, and to be more precisely, event classification. Say suppose an event, something has happened, but we want to continuously monitor that. Say suppose an event of intrusion has happened, and who is the intruder, where and all he travels. So a tracking down process has to initiate. So for those kind of applications, say suppose after an event, if a source and sink continuously try to communicate now, then those applications could be categorized under tracking. So basically all the applications could be categorized under three, like event detection, periodic measurement, and tracking. So what are the ways the nodes could be deployed in a interested area na? We can we can have a random deployment, regular deployment, or mobile sensor nodes. Random deployment is nothing but randomly dropping from an aircraft over a particular area. Usually uniform random distribution for nodes over finite area is assumed. If it's a well planned structure of deployment of nodes now, then we call it as a regular deployment. It is usually easy to maintain, wherein in this deployment, maintenance of those source nodes will be difficult. So that's what the difference between these two deployments. And there are deployments where after deploying it, you can move the nodes to the interested or the seeking out areas. So those we call it as a mobile sensor nodes. So these are the three ways of deployment options available. So one is random deployment, regular deployment, and finally after any one of the deployment is followed, you can make those deployments into a mobile sensor node deployment. So with this, I'll stop it, and we'll see in the next class. Thank you.